Alright, time for the video help for these exponential situations. This first one, you have a hot tub, it's heating up, starts at 70 degrees and increases 10% of the degrees every hour. So, when you're at 0 hours, you have 70 degrees. And after 1 hour, you got 77, okay? 10% of 70, if you're trying to do 10% and then add that to the base, you're going to times it by 1.1. Okay? When you do that, you're going to get your 77. Okay? And for each step along this table, you're going to do that. You're going to take the value, and you're going to times it by 1.1. So we're going to take 77 times it by 1.1, which is going to give you 84.7. And so on and so forth. I'm going to calculate those all real quick and put them up. Okay, now that I got those all calculated, remember to calculate all those, you're going to take the previous amount and times it by 1.1 because it's 10% more, and so what you ended up doing is times it by 110% because that's 10% more than what you start with. Okay, I also took the liberty of writing the axes for my graph here on the right side. I decided vertically I'm going to count by 20s and horizontally count by 1s because it's each hour. At 0 hours, I start here at 70, which is about right there. After 1 hour, I'm at 77, which is a little bit closer to 80. After 2 hours, I'm at 84, which is about there. After 3 hours, I'm at 93, which is going up a wee bit. At 4 hours, I'm at 102, which is about there. After 5 hours, I'm 112. After 6 hours, it's 124. Whoops, it's a little high. So the graph is curving a little bit up. It's very, very slight. So that's something that you'll probably notice is since it's such a short graph, it's small, it's hard to see the exponential nature of it. Moving on to the next questions. In this context, will the function be discrete or continuous? This one's going to be continuous. And that's because this one, when you're raising temperature, the temperature doesn't jump between the different degrees. It has to go between all of them, so it takes on all the in-between values, which is part of being part of being continuous. Y is the equation y equals 71.1x. So this 1.1x, that comes from what we times by every time, and the 70 gives us our start amount. Okay, so write that down in words. The 1.1 is our factor when we're multiplying each time. Moving on to number 2, you're at the Weasley Wizard Wheezes, and you start with 40,000. So after no years, you're starting at 40,000. You're getting 5% raise each year. So we're trying to figure out how long it will take to double it. Well, you have to get the 5% every year, and when you're figuring that out, a lot like very similar like last time, we're going to times by 1.05 because that's what 105% is. Okay, the reason I have this 1 out front, I'm not just multiplying by 0.05, is because I don't want to just have 5%. I want to have the starting amount and then get 5% more. So 5% more of 100% is 105. So that's why I'm going to multiply by 1.05. And you're going to do that for each step. So you're going to get 42 on 1 year. And then after 2 years, you're at 44.1. And you just keep going down. Again, I'm going to calculate that out and put them down. Alright, so it took a lot longer than last time to fill up the table, but it takes about 15 years to double the salary. Remember, for each step I'm multiplying by 1.05, and so it's not growing nearly as fast as the last one because it's 5% instead of 10%. So on this, plot the points, and you got it. I'm not going to plot every single one of these points because that is not a very big difference, and so my points are going to be way close together. I'm just going to skip. I'm going to do like every 5. So it starts at 40, and then after 5 years you're at 51, and after 10 years you're at 65, and after 15 years you're at 83. So again, this one is a very slight curve, but it's getting there. Okay, and moving on to the questions. Will the function be discrete or continuous? Since they're only giving you the raise once a year, that would definitely be discrete. It's not like in the middle of the year they're going to give you part of the raise, they're just giving you once a year. And the equation here is set up so the 42, that's actually the point after 1 year, which is slightly wrong. But that's basically your starting value there. And then the 1.05, that's our multiplicative factor. That's what we're multiplying by each time.